Good evening, everyone. Lovely to see all of you here in today's masterclass. I'm Siddharth. I am one of the co-founders of Gifted World, and I've seen many of you in courses or masterclasses before over the past year. We're just like 1 month away from being 1 year old here at Gifted World, and so we're very, very excited. And we also have, since you have winter vacations coming up, we also have a series of exciting courses coming up this winter that we'd love to share more details with you by the end of this presentation. So without further ado, let me get started with this. Cool. Oh no, wait. Technology. Where's the slideshow? There we go. Cool. So welcome all of you to Energized. How many of you sort of recognize that word in terms of a cultural context? Anyone? Do you see it in some kind of TV show? No? This is too old a reference. Okay, fine. We'll ignore that. Cool. So, Energize. Wait, just a quick question. Is my hand pointing towards the rest of the slide now, or is it pointing towards one side of the screen?
The rest of the slide. The rest of the slide. The rest of the
Excellent.
slide.
Okay. Thank you. Okay. So, I wanted to run this masterclass because I really feel like energy is something that cuts across everything on Earth, right? It's a really lovely way of understanding and analyzing the world around us, how it works. And of course, like energy is crucial for everything that we do. Okay. So my goal today is for us to sort of start from our everyday activities and then trace it all the way back to that thing. In fact, anyone has an idea of what that is?
No, sir.
No?
The sun.
Maybe some stones or food, or I don't know. Or maybe
For the sun.
Okay, cool. So we'll get to what that is later. Okay. No, change slide. Cool. So this is the rough plan for today's session. We're first going to talk about how we use energy. Then we're going to trace back those flows from the point of using back to where it comes from. Then we'll come to what we call as primary sources of energy. Okay, that's something that's generally talked about. But then I want to go one step further and go before those primary sources of energy. We'll look at a really interesting global map of how energy is used. And then finally, we'll discuss what does all this mean for us shifting towards a more sustainable future. Okay, so to start with, I want you to take a piece of paper or open a document or something. Okay, we're going to make a table. Yeah, we're going to make a table. Okay, and I'll show you what that table will be like. But it starts with what are all the different activities that you do during an ordinary day that require energy. So you're going to make a list that looks something like this. Okay, it's a table with 4 columns, and you're right now filling out the first column. Okay, so I just want you to list out activities. If you remember when, well, those of you who came early enough, I was asking you, what did you do in your day? Right? So take a minute to write things down, and then we'll go around and hear what everyone has to say.
What
Okay.
are we supposed to write, sir? I can forgot.
The questions up there. Questions up there? No, there. It's there. The questions up there. What are the different activities that you do during an ordinary day that requires energy? Okay, and I want you to fill out that table. Okay. So I'm seeing one category of answers, that is sports. Okay, let me. Okay, so I'm actually going to use that table over here. And I see one option is sports. What else am I hearing? So some people are saying sports, playing. Eating is an activity that you do that requires energy. It takes energy to eat. Don't you get energy from eating?
Both, sir. It takes and gives. But it gives more than it
use
takes.
some energy and you get more in return.
How do you give energy when you're eating?
No, like you use some energy and you get more from the food.
No, but what are you using the energy for?
We
Yes.
use the energy for chomping it and swallowing it.
Aha, chomping and swallowing it. Just that? Or is there anything else you're
There's
using it for?
digesting it.
Pick up the
The
food and all.
hands. The hands.
Ah,
Digesting it.
okay, digesting it. Okay, so
Sir,
I
sir, it causes because of the movement hands and movements of your organs when they when they eat digests or when they eat food.
okay, great. So it looks like there's one category of things called moving my body. Okay. And also, is my head blocking what I'm typing out?
Yes, sir.
Oh, crap.
A
Oh well.
little
Sir,
bit.
only a little bit.
Okay, so then what I'll do is yeah, okay, that's fine. So one set of things is movement. Okay. And oh, come on, Zoom. Just a minute, sorry. Ha, there we go. Okay. So I see movement as one thing. What's another one?
So maybe
Toes.
studying,
Sleeping.
because
Sleeping.
studying to me requires a lot of energy.
Okay. So I'll
Toes.
say
I
like
literally fall asleep.
thinking.
Last year, like, my mother went outside and she told me to study because my exam was the next day. I was reading my book and fell asleep.
Okay, cool. So thinking, that's fine. Oh, good.
Sleeping.
Someone has said peristalsis. Very nice. So drinking, eating. What other activities that you do you do that require energy? I see gaming. Okay,
Sleeping.
so I'll see gaming / using devices. Right? So I'll actually say sort of electronic devices. When you use
Probably,
electronic devices, you're using energy.
getting up like just before sleeping and going to turn off the light. That takes a lot of energy.
Okay. No, so that comes under moving your body, right? So now I want you to tell me something that hasn't already been covered. We've covered moving our body, we've covered thinking and sort of like the things that our body does while staying still. We've covered electronic devices. What are other activities that you do on a daily basis?
Blinking.
Huh?
Blinking.
Blinking, you're moving your body. That's fine.
Breathing.
Roughly the same.
So, organs.
Really, there's nothing else that you do that takes energy?
Organs.
Huh?
Organs.
Pump-
Your
Pumping
organs.
blood.
Organs are doing what?
Okay.
Pumping blood.
Question. So how do you move around if
Writing, I
you're
guess.
trying to go far away from your house?
Oh, in that
Legs.
walking,
Walking. Legs.
running,
Driving.
Driving.
walking or
You
running.
drive. No, but
Cycling.
also you drive, right? So walking is movement of your body. Okay, remember, I'm trying to make this list so that each entry is unique. If you're talking about walking or running, that's moving your body. Okay. So
Then basically everything is moving your body.
huh.
Sleeping.
Okay, maybe I'll jump to the next slide and this will be better.
Sleeping.
Will be clearer. Okay. So I'm going to jump to the next slide. Now can you see why I was saying that all walking, running is the same thing? Because the next thing I'm asking is what is the form of energy that you are using to do that activity?
We
So
use
that's my
food
second
and
column.
water for every activity.
Chemical energy. Chemical energy.
To move your body?
Mechanical energy then.
Yes, sir.
Okay.
But chemical energy comes from food.
Oops. Sorry. Hold on. That jumped ahead. Okay, so you guys have seen this, right? I'm just going to jump out of this presentation so that what we will do is open a sheet. Oh, wrong thing. Give me a moment. I'm just opening a spreadsheet. You're still seeing my screen, right? Huh. Okay. Sorry, technical difficulties. Please ignore. Bah. Okay, so first I should clear the annotations. Okay. So activity, energy used, source. And I'll make this bigger. So what we discussed was movement of our body. We said driving. Are there any other
Thinking.
activities that you do that take up energy?
Thinking. Electronic.
Thinking, okay.
Electronic device.
Listening.
Electronic
The listening.
devices.
Gaming.
Okay, anything else?
Reading.
Reading,
Listening.
fine, it's thinking.
Duh.
Reading is a combination of thinking and moving your body.
But reading it out loud. That's not thinking.
Fine, moving your body.
Listening.
Come on, guys.
That's
Okay,
what listening.
this master class is titled
Listening.
the sources of all energy in the earth.
Sir, can you repeat? I got disconnected.
Okay, we haven't gotten very far. So thinking, listening.
Walking.
Okay, another question I have. What happens when the sun sets? What happens in your house?
It becomes
It
dark.
gets brighter. It gets brighter because I turn on the light. It gets brighter because I turn
Is
on
that
the
an
light.
activity that you do daily that requires energy?
So that's kind
Yeah.
of electronic device. No.
It's the
Okay.
movement of our body.
So lighting.
Speakers. No, they're electronic.
That comes under listening.
Okay, no. So thinking and listening are things that your own body is doing, right? Driving slash, which is like, so this is transport, right?
Cooking.
Car, bus, train, airplane, etc.
Joining this masterclass is an activity.
Joining this masterclass is an activity. Fine. What are other things that you use that are taking up energy?
Every time I think of something, I just realize it's movement of our body.
Right. So is there something, have we completely covered everything in this list of 5 things, or are there more things?
So chemical
Standard.
fusion or something? Chemical fusion?
Chemical stuff. Okay. So can you give me an example of chemical magic that you find in your daily
Fusion
life?
and nuclear fission and nuclear fusion.
But that's not an activity, right? That's not an end
Um,
use of it. That is a source of energy.
Using my iPhone. Food.
That's electronic devices. You're using an electronic device.
But it's using battery, which is a chemical energy.
Okay, so you're saying the energy used over here is a battery.
Sir, atoms in an atomic chamber in
What about playing?
Ah,
So what about like playing with
Is it not
toys?
movement?
Sitting
Playing-
and standing.
Everything
Okay.
is movement of body in that case.
So what are okay, if we now we're thinking, remember this masterclass is to get us thinking about the whole world. So what are other things that people do that use energy?
Inventing something.
Talking.
Okay,
Sunlight.
you
Sunlight.
think cooking, for example, can I add cooking in?
No, so
We are
that's
still
not
moving our
movement
body.
and thinking.
We are still moving our body in that case.
But is all the energy of cooking coming only from moving your body?
No, it's also used from thinking to remember the ingredients.
Okay.
Okay, so are all of you cooking
Sleeping.
only by cutting things. You're not boiling. You're not
Sleeping.
grinding.
Ooh.
So where is the
Supplies,
energy? So
supplies.
today is about tracing the
Gravity.
energy.
Gravity.
Mechanical
Gravity.
supplies. Mechanical supply.
Gravity.
Gravity.
Mechanical objects. Repairing and
Okay,
breaking.
so this is a fun thing. Someone brought up gravity. So suppose you're riding a skateboard down a slope.
Muscles.
So
Okay,
breaking
guys.
something.
Okay, wait. For this masterclass to work out, we're going to have to listen to each other. So I'm going to request that when I'm talking, I'll tell you when is a good time to talk and when's a good time to put things in the chat. Okay? Where is the chat, by the way? Cooking, digestion, chemical energy, speakers in morning assembly. Party. Okay, no. So cooking, where does the energy for cooking mostly come from?
Heat energy.
So where's that heat coming from?
LPG gas.
A gas stove?
From
Like a gas?
Yes.
Okay, from gas. Okay. And now I'm going to put 3 columns that are just called source. Okay. And this is because I'm going to keep asking the question, where does that come from? Where does that come from? Where does that come from? Okay. Where does LPG come from?
From petroleum.
So it comes
Petroleum. Where does petroleum come from?
Comes from the earth.
fossils.
It comes from the fossil which are from the earth.
Where did the fossils get the energy from?
Dinosaurs.
Where did the dinosaurs get the
Animals and
energy from?
plants.
From
That
food.
Dead
energy
animals
from
and plants.
plants.
From the
Where did the
body,
plants get
from
the
the
energy
body,
From the sun.
Photosynthesis.
from the dirt, from dirt,
Dead
Okay.
animals
the
and plants.
water.
Cool. So moving your body, what energy do you use when you move your body?
Mechanical.
Muscular energy.
Chemical,
Muscular
chemical.
energy.
Chemical.
Why is it chemical energy? Why are you calling it chemical energy?
Because it's
Sir,
from
mo-
muscles.
what
Because
is
it's from
Motion
muscles.
energy.
Okay, wait.
Shouldn't
One,
it be
okay.
muscular?
Hey. Okay, folks, slow down. There are 30 of us in the room. So maybe we shall slow down. Okay. And I will ask you, like raise your hand and you can answer. So someone is saying that for moving our body, we're using chemical energy to power our muscles. Okay. Where is that chemical energy coming from? Someone said food. Okay. Now where is the food?
Plants.
Where does the food get its energy?
Comes from plants.
From the sun, from
Plants.
water, from the sun, water, plants. Depends
Okay.
on what kind we're eating. Like if we're eating plants, then the plants would get their energy from the sun and water. But if we were eating like non-veg like that, then they would get it from plants, which would get it from the sun and water. So it's
Okay.
an endless list.
So you've got plants and then sun. Okay. Now, cool. I think I'll accept that unless anyone has any.
Sir, potential or motion energy.
Okay, tell me more about it. Where do you use
Sir,
it in your everyday life?
Sir, we use it by we whenever we move our body, we use our like force. We force the body to move. Like we use potential energy in it. We're using it in our body, and motion energy when we're moving, we're using the
But
body.
what is potential energy?
Sir, it's like
We stored like it's from a height. So as soon as I drop it, it turns into kinetic and it's ready to use.
So you're saying potential energy is storing energy.
Yeah.
So
Potential.
so in all of these, is heat a form of storing energy?
Yeah.
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 Okay.
Yes. You keep it in your own body.
sir,
Is
it's a
battery a
type
way
of
of storing energy?
Of
Sir,
energy.
it's a type of energy which is stored in an object because it's like relative to other objects also.
Okay. So now, can I copy this list that we made for moving our body, right? And it's the same thing that we're doing when we're thinking or listening or anything involving our body, right? Does that make sense?
Yes.
Sir.
That when we're moving, we're using chemical energy. That's with energy that is stored as chemicals. Okay. In fact, well, we'll get to this later. Don't worry about it. There's some fun stuff about it. Now, okay, when we talk about transport, where's the energy for transporting ourselves coming from?
Petrol.
Petrol, I guess.
Energy used is actually
Petrol,
mechanical.
diesel,
Petrol,
or
diesel, energy.
electric, or electric.
Okay, where does petrol come from?
Petrol comes
Plant.
from dead plants
From
and
the
animals.
earth.
Dead plants and
Yeah.
animals.
Sir, kinetic energy.
Okay, so
Dead
petrol
plants
comes from
and-
all of these things. So once you notice, once we hit petroleum, then we know the chain back there, right?
Yeah.
Because we already did it before. Petroleum comes from fossils, from dinosaurs. Dinosaurs ate plants, and plants got their energy from the sun.
Because I just found out something.
Hmm?
So does every single energy used come from sun?
I don't know.
Because it looks like kind of here.
You're
Yeah,
right. So far, it does look
yeah.
like it. But let's see.
Almost everything is from
So now
the
this
sun.
battery. Okay. The battery in your phone.
Sir, it has
Where-
electrical energy.
Where is it getting energy from?
Sir, is
Electricity. Okay, where does electricity come from?
From
Power
power plants?
nuclear plants.
Power plants?
Okay, where does power plant get the energy from?
from devices which store the energy from thunder.
So
That's
like
all.
Yeah.
hydroelectricity plants or something.
Okay, so now we're actually okay, and I'll also anyway do lighting. The lighting in your house, where does it get energy from?
Sir, it gets from the
Uh,
power.
It comes from
Power
electricity,
source.
which comes from
Sometimes
power
solar
plants,
panels can
which
come.
come from the sun.
Okay, so now we've reached one point where we are at power plant. Okay. Are
Sir,
we missing anything else? Wait, I want everyone to just look at this and think of we'll trace back from the power plant in a bit.
Sir,
Okay.
there are many types of sources of energy. For example, solar energy, hydro energy, etc.
Yes, definitely. So Viraj, hold on a minute. I want to make sure that we feel like we've covered everything that is possible. Okay. So now I know that I've halted here on a power plant. I'm going to make the power plant yellow so that we know that we've not yet pushed it all the way back to the start. Okay. So are there any other kinds of activities that use energy in our day-to-day life?
Sleeping.
No, sleeping is same. It's our own body. It need not even be in your day-to-day life. What other stuff do you do?
Rubber bands. They use it's a potential energy.
Sir, pulling rubber bands.
Pulling rubber bands. Okay.
That's elastic energy.
We
Okay.
use electricity.
Okay. Anyone else? Is there some other different kind of activity? Madhuvanti, you had your hand up.
We use electricity
For what?
for charging our phone or
Sir, speakers.
So
Speakers.
remember, I want us to wait. Let's not talk over each other. Remember, I want us to start with an activity. Using electricity is not an activity unless you're going around and like shocking people, right? That's potentially an activity.
yeah.
Okay. But otherwise, you're rarely using raw electricity for something. You're using the electricity to do something. Now, I want to know the doing side. That's our first column. Then we move on tracing it back, but I want to start with doing.
Okay.
So feeling.
Feeling is again, it comes with this set of, so these two things involve our body. We've covered it, right? Shringa, we couldn't hear you. Playing is also moving our body.
So friction.
Friction. You get energy
Friction will
from
only
friction.
occur if we are moving our body.
No, but so for example, it's not just us who move, right? The buses and the trains are moving, and in industries, things are moving. So where all is stuff happening? And it's totally okay if you look at this and say that, hey, I think we're done. Once we feel like we're done, then we're set.
No.
We're done. I hope moving something else.
We are done.
We're done. Okay, cool.
Looking at stuff.
There's also a whole bunch of chemicals that we get, right? So we have clothes.
Sir, what about speakers? They have sonic energy.
Okay, a speaker has sound. Where does that sound come from?
Sir, it comes from some device in it. Something.
What does that how does that device make sound?
The sound is energy, so
Sir, makes sound because of
But vibration.
vibration.
But vibration.
Vibration. Okay, so sound comes from vibrations, which comes from, does your speaker work
Which
on its
comes
own or do you
from
have to do something to it?
the vibration
the
comes from
speaker.
Power-
something.
It comes from
power.
like a device that makes the vibrations.
Right, but also that needs electricity.
But
We are making the electricity.
Okay, wait, one at a time. Madhuvanti. Okay. Madhuvanti, you were saying something.
farming is part of moving our body, right?
But there are also other, it's not just the human who's doing stuff in farming, right?
Yes, sir.
Yeah. True.
So these two sets cover it when it's only just us. It's just me doing it. But then if I'm using an electronic devices, yes, I'm doing it. I'm using this laptop. But I'm also using all of these other things that are built into the laptop, which it took energy to make. Same for lighting, same for cooking. But anyway, I think time-wise, we're doing good to be
So
here.
what about painting? Like
Okay. Painting, you're using your own body, you're using colors. Where do the colors come from? Where does paper come from?
tree.
Paint comes from dyes.
Tree.
Dye of plants.
Okay. So if we're talking about painting,
Down trees. Chop down trees.
so the stuff, so the materials for painting comes from trees, plants. Where else do you get dyes from?
We can get dyes from sheep's wool. Oh no, we'll use that to dye the sheep wool.
No.
Petroleum.
Petroleum. That's a good point.
And
Why
then
why petroleum?
And then petroleum
When
is
was the
again
last time that you took oil and like crude oil and threw it on a
Because
can-
we use petroleum to make paint. That's why it smells so similar to petrol.
Really? You smelt paint and you smelt petrol. This is interesting to know about you, Srinivas. Thank you.
One of the main sources for oils.
Uh-huh. Okay, so we're using petroleum to make oils. What about clothes?
And sir,
Fiber.
one more activity.
so it's
It's fire, lighting fires. They have
That's a nice one. Okay. And fires, what energy are they using?
thermal energy.
They're generating thermal energy. They're not using it.
Frictional energy. Like
Oxygen.
That's a good point, Rizwan. It's when you are lighting a fire, you're using friction. But when the fire is running itself,
Oxygen. Oxygen.
flammable material.
Oxygen. Yeah, oxygen.
what's okay? How do you want to classify oxygen?
Like
trees.
Okay, so fires are getting energy from oxygen. So if you just have oxygen, you'll get fire, huh?
No, sir, you
and
need
like
petroleum,
Okay, are there other things that you can make fires out of?
rock.
there need to be something like that can burn, something that can
By
burn, that
grinding
the fire
metal
can
and flint together.
like plant or
Okay.
plastic or something.
two rocks together.
So grinding two rocks together makes friction, makes a spark. A spark is very hot. It can set things on fire. But there's the thing that you're setting on fire, which Adya was talking about. Indrajit, could I ask you to mute if you're not talking clearly? Hold on. Let me just make sure. Okay, cool. I think there are a couple of people who are talking without noticing. Cool. So where were we? There is something that is burning. Now, what is that something? It's wood, maybe, or gas, right? So if it's wood, where does it come from?
Sir, comes from trees, and trees come from the
What?
Trees get their energy from the sun. So we're back to the sun here. Okay. And petroleum, we know petroleum where it comes from. So now let's come to power plants. Okay. So a lot of things are running on electricity. Okay. And why do so many things run on electricity?
Because
Maybe
they need
because it's efficient.
Okay, maybe raise your hands and I can call you out to answer.
Because if we for example, if we use engine for a compressor for an AC instead of the electric compressor, the engine compressor is less efficient than the electric compressor.
Okay, so one answer why we use electricity is efficiency. Other answers?
Sir,
We
it
can do more
Wait,
things
wait,
with
I saw,
electricity.
wait, I'm like going to go with people who have raised their hands. So Shringa, you've raised your hand.
We can we use it for everyday life. So yeah, and there's many things running on electricity like devices, TV.
No, but
and
why?
many
Why? Why are you using electricity? One answer was efficiency. Okay, maybe you, so, and that was saying, Srinivas was saying that using electricity to power a compressor for an air conditioner is more efficient than using a, say, petrol generator.
engine.
Engine. Thank you. Adya, what about what?
Like we use electricity because almost everything in the modern world is made to run on electricity.
Why?
Sir, we
So
use
like
electricity because of
There are
entertainment,
more
because it is used
there
in.
are more things we can do with electricity than other stuff.
electricity electricity is a type of energy, and it is a we can use it easily, and we can transfer it from one place to another also easily.
Okay.
Energy
So
is a
here,
non-polluting.
so okay, so
Energy is a
electricity.
non-polluting source.
Sir, electricity is also used for entertainment as it power sources, gives the power source for TVs and phones and tabs and etc.
Okay, so now you can see that as we're going in this, we're going from this side, which is an end activity where it's being used, and we're tracing it back until, wait, sorry, that way. We're tracing it back until we get to the way where it comes from. Now, electricity is the medium along the way, right? So for example, let me just jump back to the presentation.
Dad.
So look at this chart over here. Okay. This is from a really lovely website that we will visit later. Okay. We started, it's the reverse direction of our table because I wanted our table to spread back out. Useful energy is something that we desire, we want to do. The light comes on, your fan turns, your TV is working. Now, that comes from electricity or charcoal or gasoline, as an example. Okay. If you're using wood to burn, to make heat, okay, that's the immediate next source that it comes from. Okay. That comes from a less refined form of energy, right? Which is electricity from a power plant or charcoal made at a kiln or gasoline from a refinery. So what's happened in between secondary and final energy is transport from the place of generation to the place of storage.
Sir, it's like a upgrade where one thing is being used for more things.
Yeah. And so the point that you made is that electricity is easy to transport. You just need to connect up wires. Okay. Instead, if you are trying to transport charcoal, to meet the needs of your home energy, that would be very difficult. Okay. How do we meet the needs of your cooking? The heat that you need for cooking, how are we making it?
LPG
Sir,
or
LPG
electric.
From
LPG
the gas, from
LPG
gas.
electric.
Okay, and how is that LPG? How does that LPG actually come to you?
LPG
Correct.
comes from
oil.
petroleum, and petroleum comes from the
No, but at the end of the
plants.
day, it's that you're physically transporting the LPG in that gas cylinder.
Then we also use more petroleum.
Yeah, we're using petrol to transport the LPG in the gas cylinder to your house. Okay, but if you think about it, there's a reason why LPG is so useful. Why would that be? Why are we using LPG instead of using electricity to cook our food?
We can it burns easily and doesn't use any electricity.
Right? But we're just saying electricity is so nice, and now you're saying you don't want to use electricity for cooking. Why?
Because LPG doesn't, it's a clean gas and doesn't give out any soot.
Yeah, and
No, wait.
Sir.
So one thing at a time.
Excuse
We
me,
were
sir.
just talking about how electricity is so great, but you don't want to use electricity for cooking. Why?
we don't use it for cooking because it's not as efficient. We can use for the heating coils and all that. We need to keep it really close. But we can use the gas cylinders for even more fires, for even more heat.
Okay, great. So I'm
We
just
need
going to put in point. Okay, why do we choose?
We need to preheat the oven to make it ready to cook, but we don't need to preheat the gas cylinder.
Okay, so one is efficiency. Some things are more efficient. You're wasting less energy. Some things are more convenient. Right? You're saying that the heat that you're getting from LPG is it's very quick. It very quickly
Sir,
goes
it's
up.
also higher than electricity.
The risk is higher.
Availability.
Okay, efficiency, convenience, availability, right? So if you were living in a remote valley in the Himalayas, you might be burning dung for heating because you're very high up, there are no trees. Okay, and this is a personal example, I've lived there, right?
Sir, those
You're
types
very high
of
up, there are no trees, so there's no wood. You're very high up, you're very far away from any petroleum sources. No one's going to send you petroleum. So what you're left with is dung, right? Dung as a source of fuel, biomass as a source of fuel. Okay. So this is why we're choosing different sources. We're choosing things to be more efficient, to be more convenient, to be more available. And I'm also going to introduce one more topic, one more reason, which is what I'm calling as energy density. How much cooking can you do with one gas cylinder? How many months, how many weeks, how often do you change the gas cylinder in your house?
Every 4 weeks or every 4 weeks.
4 weeks?
Sir,
Great.
For the small gas cylinders, but for the big ones we use it goes for
A month, I
4
guess.
months.
Okay, so what I'm hearing from you is roughly 1 month. A gas cylinder gives you roughly 1 month of use. If you try to do the same with charcoal, how much charcoal would you need?
A little more.
Just a little more? You need a lot more.
We
You
would
need
need
a
a
lot of charcoal.
whole bunch of charcoal.
Right? You'll take
You
like
would need
half a
like
room
a
of charcoal.
mountain, a mountain
And
of
it's-
charcoal
And it's
No,
not
not a
to last
mountain,
a
but
month.
you need a lot of charcoal. And here's the other thing. Charcoal itself, it takes a lot of wood to make charcoal. So the energy density, especially in an age when we're talking about electric vehicles and batteries powering things, the density, the amount of energy that you have in 1 kilogram of your fuel or of your container, or the amount of energy that you have in 1 unit volume of your container, that's very important. Okay. There are some situations where it's perfectly fine to have low energy density. If you're very close to your power source, then it's fine. But electricity is useful for all of these things. Okay. Now, funnily enough, the same thing happens inside your body. Remember, we were talking about chemical energy for your body. If we take the same image and we use it for our body, where the primary energy is food, that food in our digestive system gets converted into what? Anyone? Ideas?
Who gets converted? Energy.
Sir, glucose.
Right. So when you're very tired, or especially athletes, right, you tend to be having drinks that have sugar or glucose.
Glucon-D.
Electricity, yeah, Glucon-D. Parle-G, Glucon-D. Right? Electricity is kind of like an easy currency. We could all walk around trying to exchange bags of rice. Like, how many bags of rice do you need to buy a phone? Or how many crates of wood do you need to buy a laptop? Things like that. But we don't do that. We walk around with money. Because money as a currency is efficient, it's convenient, it's easily available. And we can now with online payment modes, it's extremely dense, right? From my phone, I can transfer thousands of rupees very easily. The body does exactly the same thing. The currency of energy in your body is glucose. Yeah, the currency of energy in your body is glucose. And do any of you have some know of, or do you have someone with diabetes in your house?
So I have a friend who is diabetic in my school.
Okay. And what does a diabetic person really pay attention to?
Blood
Yeah,
sugar,
A
blood
diet,
sugar, blood
blood
sugar.
sugar.
a sugar
Blood
diet, a
sugar,
glucose
right?
diet.
So a diabetic person is really paying attention to how much sugar there is in their blood, because sugar is the currency of energy in your body. So what you have over here in a human body or in any most any animal
Same.
is the same structure, where you're digesting, you're making sugar. That sugar is transported to wherever it needs to go. And that is the useful energy that you use. Now we'll go one step further. If you jump into a cell, now please raise your hand if you don't know what I'm saying when I mean a cell in your body. You can raise your hand if you don't know what a cell in your body means. Okay, cool. So cells are the smallest units of life. Don't quote me on that. Okay, roughly for today, we'll call it that. Cells are the smallest building blocks of your body. Okay, they're basically a little bag. Okay, it's a bag with an outer, and inside it's got a bunch of stuff. Now your muscle cells have the ability to expand or contract. And that's how we move. Because when my hand moves like this muscle is expanding, this muscle is contracting. Okay, when I open my elbow out, this is contracting, that is expanding. It's doing that by converting glucose, getting the energy to do this expansion and contraction from glucose. But even glucose is not the currency of energy of the cell, because glucose is big and complicated. So in the cell,
Sugar.
the glucose is a sugar. In the cell, there is a particular part of the cell that is a power factory. It treats the glucose that is coming in like petrol or like coal for a power plant. And it converts it into a thing called ATP, adenosine triphosphate. The name doesn't matter. But ATP is at the cell level, that is the currency of all life. All living things use ATP, from bacteria to humans. So this
Wait,
structure
so
that we're
what's
seeing over
ATP?
here,
Can you repeat what's ATP?
the name doesn't matter. Okay, but it's basically a chemical entity that can be recycled to store energy. Okay. Here's an easy way of thinking about ATP. Hold on. Right. So when we say something has chemical energy, what we mean is that somewhere in how that thing is made up, energy has been stored in the makeup of that thing. Okay. So what ATP is adenosine triphosphate. Tri means three. So it's a molecule that has three phosphates. And phosphate is another chemical entity. But I'm sharing this with you just so that you understand how is energy transmitted around. Okay. Because going into how electricity works is a little more complicated. Chemical energy is easier to understand. So what this ATP does, or what our bodies do with, or cells do with ATP, is so in the cell there's this factory that is taking glucose in and producing energy. The glucose coming in, when it's getting used up, it takes a spent ATP. So after the ATP has used up its energy, it has only two phosphates. It uses the energy from breaking down glucose to attach a third one. Now this can go anywhere in the cell, and anywhere in a reaction where energy is needed, it will split off that third phosphate and release that energy, and it will get used. Then all of these will recycle. They'll come back to the factory. Again, it will get converted into three phosphates. Then it will go wherever it's needed, split, come back. So that's how the electricity line essentially works in your cell. And now here's the fun part, right? So I told you this same structure that we're seeing on the screen is operating at the level of our society. It's operating in our body. It's operating in our cell. Because this is a fundamental way of how we organize things. Okay. So now I'm just going to jump to, okay, I'm going to jump to this chart. Okay. So where does energy come? My next question was, what did things look like 100 years ago? Now this chart on the y-axis shows sources of energy. Sorry, shows amount of energy. And the different color shows different sources of energy. The x-axis is date, different years. Okay. I'll also send this chart in the chat for people who are so inclined. Okay. So you can see 100 years ago, most energy came from biomass. And by biomass, I mean you're burning wood, you're burning dung, you're not processing that much more. Starting in the 1800s, you can see that coal really took off. Okay. Starting the 1800s, you can see that coal really took off. There are also two other things. There's hydropower and natural gas. So hydropower, which is you connect a turbine to flowing water, is again very old. Right? 10,000 years ago, people were using it. 10,000 years ago, people were using animal power. Okay. And we'll jump ahead a little more. Somewhere around the start of the 20th century, in the early 1900s, oil started getting used. Can you see how much of that power is coming from oil? And now as we go bigger and bigger, we're now in 1980, okay, which is a decade before I was born. There's oil, So previously coal looked so big, but now oil is so much bigger than coal. Right? And there's also natural gas. And there's hydropower. And then there's nuclear, and then there's hydropower. Okay. Nuclear is fairly small. I don't know if you're able to see that. There's a small amount of nuclear power. Okay. And then there's hydropower and other renewables. Okay. So now I'm moving our starting point to B. Now I just want to look over the course of my lifetime. Okay. So this is how it's looked over the course of my lifetime. There's still that same amount of biomass.
So
Since
basically,
this-
almost everything is equal. Almost everything looks equal.
So
I mean,
oil,
like almost.
coal, natural gas look roughly equal. But where do all of these
Yeah.
three come from? Oil, coal, and natural gas. Where do they come from?
Sir, they come from
Fossil.
sir, fossil.
They're what we call fossil fuels, right? All these others, where does the energy for nuclear come from?
Radiation.
Sir, atoms.
Uranium.
Nuclear fusion and
So
nuclear
nuclear
fission.
power is its own thing. Nuclear power is its own thing. It's the energy is stored in the atoms. Where does energy for hydropower come from?
Sir, water.
Where is the water getting the energy from?
Running water.
The sun.
Sir, from the speed and tidal wave.
Right. So the sun is power. You all learned the water cycle in school, no?
Yes, sir.
So the power for the water cycle is coming from the sun.
Yes, sir.
The sun is evaporating water off the oceans. It's going up into the clouds. The clouds are raining on the mountains, and then the water comes. And we can take advantage of that cycle that is powered by the sun and generate some power. Okay. Then comes wind. Where does wind get its energy from?
Heat again from the sun. Like
From
when
the air.
when
From
like
the air.
air
Yeah.
becomes hotter,
So
it
wind
rises up,
is
and
blowing
cooler air
between hot and
comes.
cold places. So that's again heat from the sun. Okay. So the thing you can see over here is that in terms of the energy currently that we're using, 80% of it roughly is coming from fossil fuels. Okay, only about 20% is coming from other sources, which then leads us to a problem, right? Okay, so now we all know that fossil fuels has led to a thing called climate change. Anyone over here hasn't heard about climate change?
Sir, climate change is due to global warming.
Okay. But
And
anyone here hasn't heard about
global warming
climate change?
because excess use of fossil fuels.
Right. So all of this fossil fuel that we're using and have been using for a really long time. And when I say we, this we is a little different, right? Because obviously people in India haven't used as much fossil fuel as people in the US, for example. Okay. All of that fossil fuel has led to changes in our atmosphere that's causing more heat to be kept on the earth. And therefore the earth is getting hotter. Okay. Now, for it to not get too hot, we need to stop using these fossil fuels.
Sir, because it harms the ozone layer.
So the ozone
Yeah,
layer
it's quite
is one of the things that has largely been fixed. The harm to the ozone layer has largely been fixed. This was a big problem 50 years ago.
Because it was fixed because of R22 to R32 refrigerant for fridges and ACs.
Yes, Srinivas, I agree. Okay, so the ozone issue is largely fixed. In fact, in many Indian cities, ozone is a pollutant. Ozone is very good if it's up high in the atmosphere. It's protecting us. But ozone, if we breathe ozone, that's bad for us. but there's a lot
Yeah.
of ozone that's being produced as a byproduct of various things. So let's not worry about that. So now here we're sitting in a situation where we have this 80% of our energy system is causing pollution that's harming our planet and our future. So how do we change this?
Sir, reduce the use of the fossil fuels.
Huh. So
Yeah.
Increase the
Try
use
using as less
sustainable.
fossil fuels as possible, reducing the use of like electronics that run on fossil fuels or
Mhm. Okay,
pollute
wait. So
the area.
I'll come before that was mostly to frame this question, and I'd like to finish off in 10 minutes so that we can answer questions. So I have one quick thing to ask about efficiency. How much? You know there is energy stored in petrol. How much energy from petrol do you think gets translated into useful energy in your car?
So like maybe like 50 gallons.
No, percent. So if I put 100% of energy is there in petrol, how much of that becomes motion in your car when you burn the petrol and run an engine?
Sir,
80%, 50 or 40.
70?
So 75%. 75%.
I'm hearing
70
70,
or
75, 40.
sir, 20%.
Okay. So let's just let's find out the way we know. Okay. How efficient is a petrol engine? Okay.
Oh,
And here is my favorite source of information, Wikipedia. Okay. The efficiency is typically about 20 to 30%.
oh. I guess I went a little too much by 70.
Yeah. So in an electric vehicle, the efficiency is around 80%. 80% of the energy that you put into a battery gets converted into motion. Now, where does
Ah.
that energy go in a petrol car? If you're saying it's only 20 to 30%, where is that energy
Carbon
go?
dioxide.
Sir, it goes.
Yeah, it turns into
Sir, it
carbon
goes to the
dioxide and
So it
harms
goes
the
into
earth.
the engine, so it powers the car to move, and then some of it is also used to for the supplies, like to measure everything, like the speed and all those stuff.
No, but I mean, energy is going somewhere. You have to be able to see it.
So
Right.
it's
So, by the way,
As
carbon
smoke,
dioxide
I
doesn't
mean, like,
contain energy. Carbon dioxide is an end product of the reaction, of the burning.
all
So,
the
where has
pollution.
that energy gone? Like that 70% of energy, where did it go?
on to
Probably
Can I
goes
request you
on.
to raise your hand since lots of people are trying to answer? Vrishan, would you like to go?
so maybe it's that energy is used for moving the car.
No, but I'm telling you, only 30% is going into moving the car. Where is the remaining 70%? What do you notice about cars that have just finished a long journey? Okay, is there some form of energy you find on them?
They become a little hot, I guess.
They become hot,
Speed.
right? If you
Yeah.
sat on a scooter, you sat on a bike, you know that you shouldn't put your leg near that exhaust pipe.
Yeah, that
Sir,
really
that's
burns
why
a
coolants
lot.
are used in cars and vehicles.
The coolant is used to keep the critical parts cool. But that heat, that is where energy is getting wasted. It's getting wasted as heat. Which brings me to the final slide of my presentation.
Sir, once our car had a breakdown because the coolant was evaporating because the car engine was so hot. We were
Yes.
going to see the Aditya launch on Andhra Pradesh, so we couldn't even call for help. But finally, after waiting for the car, we finally got it to work. But we still couldn't do with electricity. But it was 42 Celsius out there.
Okay, thanks, Srinivas. So now this diagram, and I will send you the link for it as well. This diagram is again doing the same thing that we started doing in that table, where on this side we have the useful energy, and on this side we have the sources. Okay, It's called a Sankey diagram. But this is just something that different people have produced over time to show how is energy being used. Okay. Don't worry about the numbers in there. Okay. The height of each of these, the thickness of each of these things is proportional to the numbers, right? So you can see 152 in oil is about 3 times as thick as this 54 in biomass. So these are the same sources of energies we discussed earlier: oil, biomass, gas, coal, nuclear, renewables. But as we move from the left to the right, we are seeing where is it, we're seeing where is it going. So for example, oil is generated, then most of the oil goes into direct use as fuel in diesel engines, auto engines, aircraft engines, etc., oil burners, etc. So this conversion device is what is converting that fuel, that energy source, into the final useful energy.
But sir, in oil, it's also showing a line which goes down and stops at electricity generation, and then it converts into electrical motor.
Right. So over here, this is oil. So that's why I wanted to keep this image up for a while. There are lots of lines you can observe and we can ask the questions. So that was Viraj, right? Viraj, what do you think is the difference between these two? This 13 and that 129.
I think, sir, I think that these are being used to generate electricity as when using petrol to generate electricity for electric motors.
Right. So this small 13, that small 13 over there is oil that is going into a power plant. That power plant is generating electricity. That electricity is coming to your house to run all your appliances. Whereas this 129 over here, 129 units of oil, is being directly used as fuel in engines and burners. Okay. Biomass almost entirely goes into burning. 54 units of biomass are there, 46 goes into burning. Gas, about half of it goes into electricity generation. The other half goes into burning. Okay. Coal, a lot of coal goes into electricity generation. Some of it goes into burning. Nuclear is entirely electricity generation. Renewables, the same. But now we need to see something over here. Can you see all these blue lines?
Yeah.
All of this blue is not useful energy. Right?
Then
The useful energy is just that 55.
But sir, what happens? What is that green thing? Because when coal is going down in that 87, it's getting converted to some green thing and it's going to some to the right side.
yeah,
So the
there's something green.
both the green and the blue are not useful energy.
Then what are they?
It's energy losses due to combustion. Okay, so this is combustion just means burning. Okay, so that much of energy.
Okay.
So in a diesel engine, so much of energy is just going into burning. That much of it is going into motion. So remember, we said only 30% of the petrol engine goes into motion. Motion is what you want, but only 30% of it is going into motion. In some cases, heat is useful when you're heating your house, when you're cooking, etc. So that's the useful heat. But the rest of it is being lost because it's not that efficient. It's just the way things are. It's actually a law of thermodynamics. It's the one way that the world works.
Sir, what is the meaning of internal heat exchange?
So internal heat exchange is that inside the engine, as it's operating, it needs to keep transferring heat between different parts of it. So that much of heat is going into maintaining the internal heat exchange. maybe preheating an oven is a good analogy. You need to preheat the oven, have it operating at that temperature for it to then run. So what you're doing to keep it at that operating temperature is the internal heat exchange. Okay. But here's the, and here's the interesting thing, which is the final thought that I want to leave you with before we do the closing part of this session. Now we are talking about having to stop using fossil fuels. Okay. And I told you that there's a problem that there's a problem that 80% of our energy is coming from fossil fuels. So does that mean that we then have to change 80% of our energy to come from renewables? So much energy, all of this energy, do we have to then find renewable sources for it? This diagram tells us no. Because, in fact, so much of it is being lost due to inefficiency. An electric engine is 80% efficient, but a petrol engine is only 30% efficient. So for the energy that you put in, you're getting so much more. If we were able to make things, oops, sorry, let me get the annotation in. If we were able to make things more efficient, such that we even reduce this by half. Okay. Because all of these, not even just up there, even down here, these are all losses. You can see that so much primary energy at the end of the day. So 475 units of primary energy is only going into 55 units of useful energy. What's 475 minus 55? 420. 420 is all losses. Now, some of it is
So how can we reduce this loss?
by just using things that are more efficient. Okay, so a good amount of work has to go into making all along the way things more efficient. Okay, and also we then need to be changing these sources. We need to be increasing the amount of renewable that's happening. But we don't need to be making 475 units of energy. We need to be making 55 plus efficiency losses. So maybe 100. But that's a lot easier problem to solve. Making 100 units of renewable energy is far easier than making 500. Okay. So that was the final point I want to make. Now, why am I discussing all of these things? And what's the overall context? Personally,
So I guess you're doing this because so that we can have a better life in the future for the future generation. A
I
cleaner
think we all need to be
Earth.
doing this to make our futures better.
For an eco-friendly environment.
For like for us, for our family, for our family's family. Kind of like
and
that.
I think all of us need to be doing this. And that doesn't mean I'm telling you to become an electrical engineer and like make things more efficient. Right? You can do it in whatever way works for you, whatever way you're interested in. Okay. But more broadly, what am I doing as a teacher here? What have we, the things we've discussed?
Awareness.
Trying to teach us the consequences so that we don't have to actually do them, face them.
Well, not just the consequences. Okay, so I'll just come back to this slide so that it's easier. Oh, by the way, any guesses as to what this is after everything that we've done?
Gold.
Is it like a chickpea?
Gold.
Is it a food item? Is it a food item?
So someone said it right. It's the sun. Okay, it's an image of what the surface of the sun looks like. It has all these little convectional cells, and I just tossed it in there because, as you realized when we were doing that, when we were doing this, where did my nice spreadsheet go?
But
Here.
how
What does it look like? Caramel popcorn?
how did we find out that what the surface of the sun looks like without actually going so close to it, without actually burning the satellites or rockets?
Telescopes.
Sir, because of lens used in telescopes, they can zoom in a lot.
Yeah, telescopes. Okay. So remember when we did this, it kept coming back to sun, sun, sun. So if we go back to the actual primary sources of energy, the question that we started out with, it's the sun or it's nuclear energy from the earth. Okay. There are literally only two sources of energy on the planet, the sun or nuclear energy and heat that's coming from inside the earth. About half of the heat coming from inside of the earth is heat that is left over when the earth was formed. When the earth was formed, it was very, very hot. And some of that residual heat is still inside the earth. The remaining half comes from nuclear energy that's happening inside of the earth. So if you trace back any energy that we're using on the earth, it either comes from the sun or it comes from nuclear energy and like the energy from the formation of the earth. Okay, so that answers that question. Now, where do we like, so what does this have to do with things? If you liked what happened today, I picked this topic of energy because I'm teaching a course on connecting the dots in science. It's happening during the winter vacation, so December 25th to 31st. We're going to be meeting in the evenings. And as I picked energy because it's something that cuts across everything, today's masterclass. But in this session, our focus is trying to enable you to learn conceptually. Okay. And over the 5 sessions, I'm planning to discuss these 5 topics that you can see up there. Okay. Yeah, these 5 topics that you can see up here. I'll send the website link to all of you so that you know more about it. If you're interested in joining the course, at the end of this meeting, you will all get an email with sort of with how you can sign up for the course. We'll send you the details. Okay. And personally, for me, I like stories. And if you haven't figured it out already. And so every session is tied up to an interesting story about how the world works. Okay.
Which is
So if you're-
exactly why I like to be a teacher.
Thank you. Thank you, Adya. Yes, I know several of you have been in the last course that I ran on statistics, which maybe sometime later next year I'll run the statistics course again.
Sir, I have a question.
Yes.
Before when
Now
you
we
were,
have free time for questions. Tell me.
sir, before you were saying something about triphosphate. What is the meaning of it?
Triphosphate means 3 phosphates. So adenosine triphosphate, I'll put this in the chat.
Sir,
Adenosine
it-
triphosphate is the currency of energy of chemical energy used in all biological cells.
Sir, I have a
Yes.
question. Why did we need scissors and paper and color pencils and scale?
Okay. I ran out of time, but what I wanted to do was to have us try and put these numbers out on a piece of paper. Like I wanted us to actually do the calculations of saying what is the area that corresponds to 152, 54, 97, etc. and put this out on paper. Because when you do that, you see the huge amount of heat loss. Like the huge amount, you see it as a physical thing, not just as a number on a sheet. But we took a bit longer than I expected in this tabling activity, which was fine. And yeah, so that's why.
Okay.
Yeah. And even so also wanted in general, this connecting the dots series of courses is by different mentors at Gifted World who are trying to focus on conceptual learning things. So it's connected to your syllabus, but it's sort of, we're picking topics that connect across multiple points in your syllabus. So next week, we have a masterclass by Sukanya Sinha. I will just open it for you so that you can see. Now, Sukanya is an amazing teacher, far more experienced, like she's really, really good. And her masterclass is about why gravity is so special.
So last time, didn't she teach about stars?
Yes, last time Sukanya ran a masterclass about
Yeah,
stars.
I remember.
Yeah, last
Yeah,
time she ran
I
a
was there
class about
too.
stars, and this time it's about gravity. So Sukanya is also teaching a senior track course for grade 6 to 8 in physics. I'm doing one on science. Then if you haven't already caught it, Pranshu is going to be teaching a course on generative AI for grade 6 to 8, which you can also see on our website. Then I think Sukanya again is teaching a course on math. No, not Sukanya, sorry. Kanchana, who's an amazing math teacher, is teaching a course on math for seniors. And then in April, which is pretty far away, I will be also running a course on math. And before that, I'll be running a course on computational thinking, for which we'll have another masterclass. I had a lot of fun with computational thinking. I will tell you when it's coming up next. But we got a whole bunch of courses coming up if any of you are interested in looking for excitement over the winter. And now questions. Anyone has questions? Questions. I see something about type 1 civilizations and type 0.7 civilizations.
Sir, so what is the picture?
The picture.
Yeah.
Here, let me show you the source. There. That's what the surface of the sun looks like.
Oh, okay.
So that's what the visible surface of the sun looks like. And it contains all of these cells of convectional energy that are going back and forth. What's a good way of you seeing these? It's sometimes possible in thin layers of oil on a pan form these convectional cells.
Oh, okay.
Okay, and
Does it look like caramel popcorn?
cells on a cooking pan. There we go. Ta-da. There you go. So you can use soapy water to make this. Yeah. So the exploratorium has a thing. And
are you looking at the roiling, churning surface of the sun? Or is it just a pan of soapy water?
cool. So that's how you can do it. Anyway, questions. Vrishan has his hands up. Go, Vrishan.
I was just saying what the caramel popcorn and something.
Okay, cool. Thanks. Viraj, you have a question?
No, sir.
Okay. Anyone else with questions? We've got 5 more minutes. And let me check the chat also. Someone said glucose. What does glucose have to do with things? Okay, you're all figuring out how to. Can I have a show of hands? How many of you are in Bangalore? You can raise your hands on Zoom, please. That's easier to count. Okay, we got 1, 2, 3. We're thinking about having an in-person meetup at some point of time in Bangalore. Okay, hence there are 3 people in Bangalore, so that's not that useful. How many people are in Pune? Pune? Any Pune people? Okay, no Pune people. Mumbai? No Mumbai. Okay. How many people are in Dubai or the UAE?
There is.
Oh, this is a solid number of UAE people. Okay, cool. So anytime any of us are around that side, we will make a meetup happen. Excellent. Can I ask one more question? Because I usually like asking this. What subject do you think you learned today? If you had to think about, compare this to your school subjects.
Science.
Chemistry.
Chemistry.
Science.
Science?
Science.
Okay.
Science and
Biology?
EVS. Both.
Science.
Biology.
Okay. If you had to go smaller than science, like you had to make it smaller than science, like that physics, chemistry,
like-
biology,
like
business, that you talked
Chemistry.
about.
Chemistry and biology, kind of a combination.
Science.
Okay.
Physics.
Biochemics.
So biochemistry.
Hey, I've not done a biochemistry class yet. Okay. There was a bit of biochemistry in it. If you want, I'll give you a proper biochemistry class, but that's great for a 10, 11, 12-year-old is it might be a little early for biochemistry. We can do it. I'm happy to, but okay, cool. Anyone else? So any questions? Sorry. Questions? Excellent. So thank you all for coming today. If you're interested, please do sign up for the course. I will send you a 15% off coupon after this meeting, and I will also just drop that coupon code in the chat. Hello. I'm going to stop my screen share, then that will be easier to do.
Well, thanks for the class.
Yeah, and we'll put up this session on YouTube soon enough. This coupon code will give you 15% off on any of the courses that you want to do in the Connecting the Dots series. So all of them will be online, and timings and everything is up on the website in case you're interested. Anyone else? Someone said something. People are talking about their own channels. Excellent. Yes, I have taken note of it. Cool. So